Alright, so this is section 7.1. It's our introduction to solving a system of linear systems by graphing. And the essential question is, how do we solve a linear system of equations by graphing? So before we begin, I do want to talk about a little warm-up here. So what I want you to do is I want you to graph 3x minus 4y equals 12 on this coordinate plane and realize that this is in standard. Alright, hopefully you've got an answer, but there's one way you can do it. We can change this into slope-intercept form by saying negative 4y was equal to negative 3x and then add 12, and then divide everything by a negative 4. And so we would get y is equal to 3/4 x and then minus 3. So I'd go down 3, 1, 2, 3, put a dot, and then the slope is up 3 over 4, so 1, 2, 3, 1, 2, 3, 4. And then I would draw my line here. So that's just remembering how to graph an equation that is in standard form. Okay, let's get into now what is a system of linear equations. This should be linear here, system of linear. And the definition that we're going to use is basically just two or more equations that are solved together. Solved together. So that's basically the definition here. That's our definition for a system of linear equations. It is two or more equations that is solved together. So here's an example. All right, here is an example. I've got y equals 2x plus 3 and y equals negative 2/3 x minus 5. All right, so what I'm going to do is I'm going to graph both of those. Let me put this on here for us. I'm going to graph both of these on the coordinate plane. I'm going to make this a little bit smaller so we can all see it, and then sort of take a look at it, okay? So the first one I'll do is I'll graph in black y equals 2x plus 3. So I'm going to go up to 3, put a dot, and then go up to 1, 2, and then over 1. And this is the equation 2x plus 3. 2x plus 3. There's that one right there. Okay, then I'm going to choose a different color, and I'm going to graph this one. Negative 2/3 x minus 5. So here's 5. Okay, and then I go down to 1, 2, and over 3. 1, 2, 3. So if I go up to 1, 2, 3, up to 1, 2, 1, 2, 3. Oh, I think it's right there. I did that right. Okay, so now I would draw a line, and I'd see something like this. That's pretty bad indication of what's going on there. But anyways, we see that at somewhere these lines meet. Okay, and the point at which they meet is what we're going to call the solution. The solution to the actual system. It's the one point. The solution is going to be x comma y. It's the one point that makes both equations of the system true. Okay, so that's what we're going here for. That is a solution to a system of equations. So a great question that we could ask ourselves on the left-hand side of our Cornell notes would be, what is a solution to a system? Okay, if you can answer that question, then that would give you full sort of master over that particular idea there. So we're looking for where these two lines meet. So we're going to graph one line, graph the other line. That's our system. See where they meet, and that would be our solution. So let's do an example together here. So I've got 3x plus y equals 9, and x minus y equals negative 1. So I'm going to graph both of these together. I'm going to choose to turn these into slope-intercept form. So that's going to give me y is equal to negative 3x plus 9, and this one is going to say that negative y is equal to negative x minus 1. So y must be x plus 1. There we go. That looks good. So I have these two linear equations here, and I'm going to graph this one in blue, and it's going to be go up there at positive 9, so that's 6, 7, 8, 9, so somewhere up here. Okay, and then I'd go down 3 and over 1. So down 3 and over 1, that would put me at this point, and I would go down 3 and over 1, so it would look more like this. All right, something like that. That's my first line. That's my blue line. Then in red, I'm going to graph y equals x plus 1. So I'm going to go up to 1, go up 1 over 1, up 1 over 1, and it looks like this right here. So it looks to me like I'm guessing that the solution is the point 2, 3. So that looks where they are intersecting. So how do I check to verify that's true? So let's check my solution. Now remember, this was the system I had before. 3x plus y equals 9. I had 3x plus y equals 9. And I also had, the other one was x minus y equals negative 1. X minus y equals negative 1. So what I'm going to do is I'm going to test this point 2, 3 in for each of those. This is my x, remember, this is my y. Alright, so let's see here. 2 times, whoops, sorry, try that again. 3 times 2 plus my y of 3, does that equal 9? Let's see here, 3 times 2 is 6 plus 3 equals 9. Yep, 9 is equal to 9. That is a true statement. Awesome. Let's test the same point over here. I had 3, and then it was x, 2, 3. Sorry, my bad. So we go 2 minus 3. Does that equal negative 1? And of course, negative 1 equals negative 1. That is also true. So it seems to be that this is the only solution for this system of equations. And that's how you solve system of equations by graphing.